over there a faint speck of light. The image of the night sky was taken by a telescope in the desert of Chile on July 1, 2025. At first glance, it appears to be just another cosmic explorer. However, within hours, astronomers become aware of their error. An extraordinary event is unfolding. An object is accelerating from beyond our solar system at a staggering 130,000 miles per hour, heading toward Mars. This is the third interstellar object ever discovered, 3I Atlas, and its discovery has shocked everyone in the scientific community. Unlike anything we've seen before, its trajectory raises questions that go much deeper than the simplest flyby. Is it a relic, a natural comet from a different system of stars, or something more? What implications does it have for Mars and possibly Earth? Let's get started on this cosmic mystery, the story of 3I Atlas that's rewriting what we thought we knew about our position in the universe. If that sounds interesting, stay with me. Hit that like button and let's look into this together. The asteroid is where the story begins. Atlas System, or Terrestrial Impact Last Alert, is a network of telescopes designed to spot objects close to Earth before they become threats. Atlas was born that fateful July day when it flagged a light moving quickly, unlike any other comet or asteroid in our solar system. It moved too quickly, its path too unusual. Soon after, the Global Clearinghouse at the Minor Planet Center, responsible for observing spacecraft, issued an interim designation, 3I Atlas, declaring it an interstellar interloper. Only two of these had been confirmed before, in 2017, Oumuamua and Comet Borisov in 2019. However, 3I Atlas was unique. Its hyperbolic orbit and bound by the Sun's gravity confirmed that it originated deep within interstellar space, and its course was moving it in the direction of the red planet. At a speed that could cross the United States in under a minute, this was unlike any other space rock. Scientists at NASA's Jet Propulsion Laboratory scrambled to calculate its path, and what they discovered was both thrilling and unsettling. Let's discuss what distinguishes 3I Atlas as so original. Initial findings suggested it was massive, potentially 20 kilometers across, twice the size of the Chicxulub impactor that drove the dinosaurs to extinction. Its velocity, clocked at 36 kilometers per second, placed it among the fastest objects ever tracked. That's sufficient to get from Earth to the Moon in about 3 hours. Data from the Atlas telescopes estimated its size, but the real puzzle was its behavior. In contrast to typical comets, which emit gas and dust chaotically as they heat up, 3I Atlas showed signs of accuracy near the Sun. Over 30 days, it executed 14 course corrections, exactly one every 17 minutes, adjusting its path with a degree of precision that confused scientists. These were not sudden outbursts, they were planned, clockwork-like maneuvers, shifting its trajectory by over 50,000 kilometers, enough to divert it from a safe pass-by to a direct collision course with Mars. Harvard astrophysicist Avi Loeb, a leading authority on objects from other stars, called the likelihood of this occurring astronomical, estimating it as a 1 in a billion years event. Thus, what was causing these alterations? Are we witnessing physics we don't yet comprehend, or something else entirely? As astronomers gathered more data, the stakes grew higher. NASA's Planetary Defense Coordination Office, charged with safeguarding Earth from cosmic threats, carried out simulations using JPLS Horizon System, the gold standard for orbital calculations. The outcomes were mind-boggling. If 3I Atlas struck Mars, it could carve a crater 60 kilometers long and 5 kilometers wide, larger than the planet's most recent impact site. The amount of energy released would equal millions of megatons of TNT, outweighing the total force produced by every nuclear weapon ever built. To put that in perspective, the 1883 Krakatoa eruption, one of the most powerful natural disasters on Earth, released just 200 megatons. This impact would be 10,000 times more powerful, vaporizing rock, melting bedrock on Mars, and generating shock waves worldwide. The aftermath wouldn't stop there. Billions of tons of the atmosphere would be inundated with dust, plunging Mars into a years-long twilight. Temperatures could drop by 20 degrees Celsius, carbon dioxide could freeze, and polar ice caps could thicken. Every rover, orbiter, and future mission site within 1,000 kilometers would be lost. Mars, a harsh planet, already would become even less welcoming. Yet here's the highlight. Some of the debris could escape Mars' gravity, scattering into orbits that may eventually cross Earth's path. Could this visitor from another star system pose a threat to us? Let's keep digging. There was a buzz in the scientific community, but the narrative developed behind closed doors in a darker direction. Leaked documents from JPL revealed internal debates about the simulation results. Some researchers argued in favor of transparency, believing the public deserved to be aware of the magnitude of the potential consequences. Others, including defense officials, urged secrecy, citing concerns about national security. Why? Unsettling information was suggested by the data. The 14-course alterations of 3I Atlas might not be natural. Each pulse, the precision of its gas maneuvers was perfectly timed and directed, modeling the actions of a spacecraft rather than a comet. Spectral data added fuel to the fire. Observations from the southern European observatories, very large telescopes, spotted metallic glints emitting spectral lines matching iron and sodium materials far more typical of meteorites or alloys than of icy comets. These flashes occurred simultaneously with the object's course corrections, raising concerns about whether 3 Atlas possessed an organized, possibly artificial surface. Official statements from NASA minimized the risk and emphasized the scientific opportunity to investigate an interstellar object up close. Yet the leaked models painted a different picture, one of a terrible incident that could alter Mars' shape and cause ripples through the system of stars. Let's step back in time and examine Mars' past to understand why this matters. The Red Planet is no stranger to cosmic violence. The 2,300 kilometers long Hellas Basin, a wide scar in its southern hemisphere, was carved by a massive impactor. 4 billion years ago, a smaller moon created the Borealis Basin, which encompasses nearly half the planet and tells an even older tale. A collision so massive it may have wiped out much of Mars' early atmosphere. These ancient impacts left isotopic signatures, heavy metals, noble gases, and clues that hint some of those objects originated from beyond our solar system. Now, 3. Atlas threatens to add a new chapter to this history of violence. Its potential impact would be larger than craters like Zunil, which spans just 10 kilometers. The dust clouds alone could trigger global storms, preventing sunlight from reaching the surface and delaying any possibility of human exploration for decades. The long-term risk is even greater. Debris from the impact may drift for years, possibly making its way to Earth. NASA's models estimate that within 7 to 12 years, fragments could cross our orbit, posing a low but non-zero risk of secondary impacts. Our current planetary defense systems were not designed to handle such scattered debris. A chilling question arises: are we ready for the consequences of an event like this? Now, let's address a common misconception. Online forums often claim that 3 Atlas is an alien spacecraft deliberately aimed at Mars. Despite the data, its precise adjustments and metallic signatures are intriguing, but jumping to extraterrestrial conclusions is premature. Natural explanations, though strained, remain possible. Interstellar objects could form in metal-rich environments around distant stars. Rhythmic outgassing may result from unique internal structures or thermal cycles that we have yet to model. ESA comet expert Marco Full cautions against overinterpretation, reminding us that nature often surprises with its complexity. Still, the debate persists. The consistency of the object's movements and its spectral anomalies don't fit neatly into known models of comets or asteroids. Before we can investigate 3 Atlas up close, perhaps with a future mission, we're left with tantalizing hints but no definitive answers. What do you think? Is this just a bizarre rock from space or something more? Leave your comments below and let's continue the discussion. The human element of the story is equally compelling. Imagine being the JPL analyst who ran the initial impact simulation, watching the monitor fill with color-coded maps of a 60 kilometers crater. The weight of that moment knowing the data could alter our understanding of Mars, and our place in the cosmos must have been overwhelming. Researchers like Avi and Marco Fool have devoted their careers to mysteries like this, piecing together hints from faraway stars. Their work, built on decades of observations and calculations, reminds us that space exploration is a human endeavor, driven by curiosity and collaboration. NASA's Planetary Defense Coordination Office, working with global partners, embodies this spirit by sharing data across worldwide observatories to monitor 3E Atlas in real time. Yet internal debates over transparency highlight the challenge of balancing scientific openness with public perception. So, where do we go from here? The discovery of 3E Atlas reminds us that space is full of surprises, some wondrous, some terrifying. It underscores the importance of planetary protection, not only for Earth, but also for our long-term goals of exploring and one day colonizing Mars. Every trajectory and spectral reading we collect now is a treasure trove for future generations. It's a call to invest in advanced telescopes, robust simulations, and global cooperation to prepare for whatever comes next. Whether 3II Atlas is a natural marvel or something entirely different, its journey is a wake-up call. The universe has no regard for our plans, it moves on its own terms, and we must be prepared. Let's wrap this up by considering what 3E Atlas represents. It offers a glimpse into the vastness of space and a reminder that our solar system is just one small corner of an unending universe. The numbers alone, an estimated 60 kilometers crater releasing 2 million megatons of energy and 14 precise maneuvers, tell a story of immense power and mystery. Mars, with its ancient scars, has already borne witness to such events. For us, it is a chance to learn, to prepare, and to wonder. So, keep looking up. Keep asking questions. Stay curious. If you enjoyed this deep dive, give it a thumbs up, subscribe for more space explorations, and share your thoughts in the comments. 3II Atlas. What is it? And what should NASA do next?